Hey, how you doing? It's Dr. Bab. I'm speaking to students in CIDM4310, 5310. A slightly belated video on chapters 4 through 7. I know you've already quizzed on these, but I thought it would be worth exploring some of these concepts. Generally, what Sherman is doing in this part is really talking about, all right, we kind of know conceptually we need to deal with this data, and we need to then kind of articulate uh, the case for that. And this book is a 2014 book, and in a lot of ways, popularly almost, this case is well articulated, but it still has to be actuated or affected um, in an organizational context. The other interesting or challenging part of this is that we are going to have a difficult time as students of this fully engaging in all these technologies because, quite simply, we don't have a particularly large trove of operational data. We have a reasonable access to kind of free aggregated data. That's why I had you guys go out to data.gov. Um, a sort of U.S. taxpayer dollars go towards funding this kind of thing, but it's not kind of the juicy operational data you could get from a place like Amazon.com, right? That would be incredible to be able to get this. I have a favorite go-to. I usually like to use aviation things. And I'd love to get you guys to get some operational data here off of FlightAware. But the issue is it's going to cost money. And I'm a little hesitant to at least push that too hard. I will probably demonstrate it. It would be best if you all could really get into this yourself, and we'll see. I have a couple other data sets. I have a data set, very large, 40 gigabyte data set for you to attempt to obtain that has a lot of data that can use some cleanup. But we're going to end up doing exercises that are tinier than um, what we end up actually engaging in the book. So the book's kind of big picture. The other book I asked you to get um, is really just some thoughts. I think the Knaflic book, it's a light, almost coffee book. I'm going to kind of rely on you looking at it, frankly, quite a bit on your own. I want you to be kind of self-directed, but um, what this person talks about is just sort of thinking about how things to keep in mind when you build presentations. So every time I ask you to do one, and I saw some comments like, "Hey, what do you mean by storytelling?" Um, it's kind of from here. So the idea then is as you look to justify or rationalize or validate the ways that you do this, just try to reference and make um, sort of good use of this book. When he talks about thinking like a designer and gives you some things to think about in terms of just limiting distractions and um, categorization and accessibility and all these sorts of things. Just sort of consider um, going by his example, right? So, what does this have to do with the lecture? Um, well, what we start off with is Sherman telling us, well, listen, um, at least to understand this, you can kind of think about overall architectures. And what we mean by overall architectures is that there's the need to reconcile with these major moving pieces. This is big picture, 10,000 miles high view of the deal. At the end of the day, the organization needs information. And so, as such, let me see if I can flip this thing over to um, 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 the presentation itself. Let's see. That's kind of not what I want. So I did this because I think you can get like fun things like a laser pointer. I think that's kind of redundant because the recording tool does this as well. Here, I'm going to want to show you other things anyway. So let me get out of presentation mode here. Just show it kind of more raw. Now, in order to do this, you need to think of a technical architecture. That is, what's going to facilitate the ability to um, develop products that can glean the required data and information that can lead to the intelligence and the knowledge that feeds intelligence. So the direction on the left of you need to be able to define priorities and requirements, right? So what is it we need? What do we need first? Of course, the ideal answer is I need it all and I need it yesterday, but that's not feasible. So a lot of this entire part of the book is reconciling these things. So we kind of get the need or the conceptualization, I guess the articulation that really we're taking this enterprise quote unquote level. And I think enterprise just is kind of code for large with many moving components. Particularly, I mean, what is a decent definition of enterprise, right? Now, enterprise is a English language word that means quite a few things, right? Um, but it's certainly it means a business or company. But generally, what kind of keeps it a little bit more enterprise, in terms of what makes it um, profound, is that it has a lot of usually multifaceted entity, right? So there's a lot of subcomponents of this organization, um, particularly, being very goal-seeking and resourceful with quite a bit of initiative. But it's kind of loose. I think it just becomes code for serious business, and I don't want to be trite. It's just that really kind of feels um, largely, the case. So what we see here, sorry, I'm just trying to pull up a resource for us to look at. So what we see here is a conceptualization of the inputs and outputs to this enterprise data warehouse. And the whole point of a data warehouse is to say that we're going to need to stockpile and organize and make available for subsequent use um, quite a bit of these data resources that we're going to need. And so you can see that they're largely going to come from what the book describes as a system of record. And a system of record is going to just quite simply be which systems are within our purview, generally owned, operated, and otherwise we're responsible for, although that can become messy and that can extend to beyond this, particularly in a service-oriented architecture. But what are these systems that we generate, rather that we own, maintain, operate, design, etc., that lead to the types of data which we then want to analyze and process for the purposes of information to glean operational intelligence. So draw your attention to the left column here. So the systems of record is they're going to be enterprise applications. Generally, this just means it cuts across multiple subunits. To take the university as a exemplar, sort of like the student management system, given that that's kind of the big reason why we're all there, why the university exists, cuts across functional units. Customer relations management, cloud apps and databases. So sometimes these are oftentimes forward-facing, things to deal with the various business processes. The registrar's office, human resources, physical plant. Just sort of data services that we might actually subscribe to. So for instance, I really want to use this example, but I can't find a decent substitute for you guys not spending money. But so again, this FlightAware here will allow you to, here we are, products, live data feeds. So you can actually get live information. This is the one I really want you to try to use, this Flight XML API. you can get you can subscribe to a service like this, and trust me, they're a dime a dozen. I mean, even data.gov, which I was showing earlier, has things that go to developers here, has basically APIs, ways for us to um, consume various services in here. So there becomes quite a few options for your business to be able to pull in information as a service. There are also a lot of unstructured documents generated. When you look at technologies like SharePoint, it's usually kind of an attempt to um, tame these. And then kind of, I guess that's a mistake in the diagram, but full circle back to enterprise applications. So these things need to be put together. Now, architecturally, we have this type of workflow for our data. And don't forget, we're going back to we have a data architecture and information architecture, technical architecture, and product. So we need to take these various sources, and regardless, no matter how much you would try, these are not naturally going to lay against each other cleanly. They are different operating. I see this all the time, and it's typically the type of problem I'll sometimes be called in on. I should do it more for consulting than I do, but around the Panhandle area of Texas, we'll just get different people saying, we have a question about this. Do you have a student who can do this? And they almost always end up becoming these integration problems. So the data integration says that how can they be put together such that they can become um, uh, be fed into the components of our own data warehousing. So the idea is if we were Amazon, for example, and we have a series of products we're looking to fulfill for consumers, we're going to stage this information probably at transit hubs, logistics hubs around the world. And the metaphor is fairly strong for data itself. So there are kind of concerns of staging, and the staging, of course, is how can we sort of get it prepared to be available. There are components to be concerned with respect to the enterprise warehouse itself. There are components of data marts, operational data systems, and even something highly processed called an OLAP cube. So in many ways, we're talking about sort of the different strategies for um, uh, data warehousing. And of course, I'm sorry, I skipped over MDM, master data management. That's a term I really only encountered here in Sherman's book. I don't want to give the sense that it's not some kind of common thing. It's just not maybe something I run into as much. Trust me, in the BI world, there's an entire lingo here, and a lot of these, you know, companies like Oracle and SAP and whatnot, who are really out to act as vendors in this space, they're kind of popularizing this. And again, that feeds into our various business intelligence, dashboard making. You kind of just see from the pictures here. And so even the first assignment we've done together, where we've really worked with Tableau and Excel, that becomes fairly common. It's like one of the next horizons we want to accomplish is to look at relational databases, and we want to look at maybe working even with some services, basically some REST services. So this is the general flow you would expect, is that you need to work in each of these, and we want to be exploring these in some of our activities soon. So when you're actually architecting for business intelligence data, we want to be cognizant of the roles of these different data systems. And what this really means is that as we moved between these architectures, the data systems that we're standing up here are data warehouses or marts or what have you. And we have systems of record, systems of integration, and even systems of analytics. These come together to generate our business intelligence. So again, our systems of record are essentially where we capture data, at operational and transactional applications. Generally, This is how the people and processes involved in enterprise really generate what we need to know about. So integration then is that they're, no matter how much we try, they generally just don't show up clean. It's really the 5 C's here, right? Consistent, conform, comprehensive, clean, and current. Then we would then want to think of the architectures as being a system of analytics to provide the digested data and to kind of capture those decisions so they can go back to operations. And so that's another way of conceiving of what it is that we're doing and are trying to accomplish here. There's going to be a technical architecture to be concerned with. And this is just the technologies that are used to implement and support the BI solution. So this isn't necessarily the products. So the technical architecture and the products themselves are not the same. Um, this happens when basically you kind of have a vendor that is supplying both to you, right? I'm SAP, and I've got a turnkey solution here, end to end, out of the box. And I don't know that all operations are that clean, nor are there for various maybe organizational or operational histories that you'd be using everything from a vendor. You usually have legacy systems that you can't even afford the integrations that these turnkey systems providers want to do for you. So we really go from the sources to the integration to the warehouse up to the tools for business intelligence. So this is going to lead to various technical architecture categories. So if we look down here in data sources, there are application services, either ones we produce or consume or both. Some of these live in the cloud. Some of these derive from your, shipping, receiving, R&D, whatever, your functional units. Um, this also leads to just having a lot of your own, whether you built or bought enterprise applications, data services. We've gone through these before. Even sort of social, I like how they've done that. Increasingly, depending on what business you're in, you want to be pulling in information in real time. One nice one, which I think we'll be able to play with. I'll have a lot more for you after this um, next weekend in June. I guess the third, possibly the last weekend in June. Um, so this Twitter API is something we're going to want to play with, right? Because it's always very interesting to see, can we kind of tap into the zeitgeist, is one word for it, based on your area, based on a topical theme. It really just depends. So um, then, of course, our concerns of data integration are how do we prepare or stage visualizations, extraction, transformation, loading, or extraction, loading, and transformation. Fairly interchangeable concepts there. Um, does this change any of the data services we subscribe to? And then, of course, you might have certain repositories expressly for integration. And then you want to have certain meta records to help you with master data management. These then feed the various warehouse and warehousing products, some places for staging, analytical sandbox, just sort of what if playgrounds, BI repositories, data you've really prepared specifically for the BI products. You sort of have operational data store, I'd say. Somebody like Amazon has a lot closer. So anyway, and we're still going to have some unstructured databases because some things are just fairly ad hoc. And this is going to feed your various management and decision-making focused tools here. So we can break each of these out. So there are various analytical BI styles. So some things are really heavy on visualization. Some things are heavy on visualization and discovery. Some things just got to have to work on the road, so they're going to have some limitations in terms of real estate for analysis. Sometimes they have to be shared with customers. Sometimes we need some pretty big time predictive analytics, so pretty serious modeling here. And sometimes we just have good old-fashioned reporting. So there are going to be a number of BI styles that we have to facilitate here, a number of products we might store. So this is just breaking each of these down individually. So this is a pretty great graphic, and Sherman shares this graphic multiple times in these chapters. And what this says is that over time, as data has expanded, we've seen these different types of database products, these different types of sort of BI concerns and buzzwords as they've transformed through these different enterprise applications and the various technology platforms. So they're really kind of great to look at. Um, in let's see if I can get some of these tools going here. Let me switch this guy over. So they're really kind of great to look at. So here I would say we had certainly 60s, really into the 70s. So it's quite simple. We had a monolithic mainframe, very likely from IBM, although it could be from the other vendors at the time. IBM kind of persists from that era. Um, Digital is another company that comes to mind. Excuse me. And there are various operational applications, which is essentially just sort of real-time, things that kind of, keep retail running, shipping and receiving running. And then generally, if you look at sort of languages like COBOL, right, common business-oriented language, they really have a history in being there for reporting. And generally, we're reporting on just snapshots of the real-time data. So pretty simplistic stuff. Then we get into, let's call this the 80s. So I'll put 7 here and 8 here. The advent of, the Moore's law taking effect, the shrinking and expanding of computing, but that is the shrinking of the physical component of computing and the expansion of the processing power of computing. That miniaturization, which concludes all the way up until the upper ends of this list, the constant miniaturization, and the miniaturization also led to less power consumption. So this miniaturization of the actual physical hardware has led to some changes. So we have enterprise resource planning, which is kind of coming off the mini computer, which said that maybe different functional units could actually have their own computers there. We didn't have to have the bottlenecks of central processing. This is when, excuse me, when decision support systems were pretty, these are sort of like the buzzwords of the time. Really moving on to files that can live in more than one place. We just don't have this central repository. Um, basically, the PC and the client server. We get into things like data mining and having data marts and warehouses and the advent of relational databases. And what's interesting is that many things still rest. I mean, the large swath of concerns, the things you'll find even in the curriculum, such as ours, a lot of the academic papers written, they shockingly still really focus on these lower eras here. There's not, massive variance from these really, which is rather interesting. Let's see if we can get a different color. We'll go into the 90s for sure into here. 90s. I'll kind of put these guys together. So the 90s give us the advent of the web in the early to mid 90s. This idea of industry applications, which sort of says we can kind of start to have differentiated by industrial sector, differentiated by domains or disciplines. The idea of ETL is that since we have so many of these disparate systems back from these technologies in the 80s, the mini computer, all that, is they're starting to generate similar but then yet dissimilar data. So the online these OLAP analytics, sorry, online analytical processing cubes here, which is the idea is that we have these sort of distinct uh, chunks of kind of prepared data. So it's the precursors of data warehousing and data marts. The ability to have more sophisticated dashboards for the decision makers, having a lot more of a hub and spoke system, which means that because we have computing out into the various even branch locations, that is, different offices around the country or world, networking had improved. Boy, I like this one a lot. You cannot underestimate the impact of open source software since easily that 80s, 90s divide. Enterprise resource planning, data warehousing, consolidation, enterprise resource. So that whole enterprise resource planning was a big deal. Federating of your data marts, that is to basically you have them distributed probably across functional units or geographic units, enterprise applications integration. So this is still in the parlance, but these were really just expansions, if you will. So like really big revolutionary markers here. Let me pick a different color. Probably huge revolutionary markers is certainly this mini computer PC thing, certainly the web, certainly the maturation of the web with respect to JavaScript, absolutely mobile, and I would say definitely even social media in the Nexus IoT. These are definitely big markers. If I was reading, this was some sort of medical chart and I was the doctor, I had to interpret it. These are milestones. These are important milestones. And the eras that I'm delineating really kind of correspond to them. So Web 2.0, this is the aughts, really actually all the way up into tablets. Let's see if I can craftily do this. So that's the 2000s. And Web 2.0, kind of coined about 10-ish years ago. Smartphones, as we know them, really about 8 years ago. Web services. So this is this, particularly web services as they deal with REST, representational state transfer. The XML SOAP standards were pretty important, but I don't think that they won. What won is things based on JavaScript. So that's the big technology I would sort of point to from this era is JavaScript. Um, so we have these different buzzwords here. Not, I'm going to be honest, not all of which I've kind of internalized. In fact, I'm going to have to look up really quickly here. What the heck an MPP? Whoa. Um, yeah, keep these. What the heck an MPP database is? I have to admit, I don't remember reading that in the book. It doesn't mean it doesn't exist. Um, oh, parallel. Massively parallel processing. Okay, I got it. That makes sense. This is how these are the concerns or problems that Google has, or Amazon has, or heck, even Facebook. All these people, they're just massively distributed parallel processing, and they have to keep these things reconciled. Okay, that makes sense. I suddenly get it. Where did you go? Showy thing here. Okay, great. Now we're into current events. Let's get a new color. Current events. You gonna work for me, everybody? I thought I had a highlighter. Highlighter. No. Highlighter blue. This here is the tens and the teens, I guess. These things, software as a service, cloud, moving things into the cloud and mobile, right? So these become really a big deal. IoT, it's huge because it sort of pretty much says because of the miniaturization of hardware, we increasingly have the ability to, and don't forget, this means low power consumption. We have the ability to get processing and data collection out anywhere. You know, if it's where business transactions are, consumers are, um, any sort of operations are, we're going to be there. So we get a resurgence of BI, resurgence of concerns with BI, resurgence of analytics, particularly to be able to do predictive analytics, real-time in-memory analytics, data visualization makes a resurgence, all these things. So, if I had to redo it, I probably would even consider designing the course along this sort of walk through history. As it is, the next thing we need to do is just look at some database stuff. Um, so I like this picture a lot, and it rears its head again in several of the chapters. But so there's that. Okay, let's sure keep the inks, please. All right, so what does that mean? So in chapter 5, what our friend there it is. I was just looking for kind of some notes I have off to the side here. So in chapter 5, what our friend Sherman does is talk about, okay, so we've talked about your data, but we know that the data has to be transformed into information. And this is where in the chapter, he discusses some of these really important questions. You want to start asking decision makers, management, key stakeholders, power brokers, and tastemakers. Um, what are you trying to do? What do you need to know about? What kind of decisions and outcomes of this? Who between your employees and customers and prospects and suppliers and stakeholders and just who in the environment, people-wise, is going to have access to this information, either as a consumer or producer? Um, where's the data? Where will you be integrating it? Increasingly, the answer to this is I can just actually do stuff as a service. And that has some real implications because if people either A, go belly up, I don't think Amazon will anytime soon, or Microsoft, or Google, but or if you start to trust this data elsewhere, how do we know we're not going to have a massive breach? And what does that mean for you? So, um, where are people going to use this? Is it mobile? Is it on the road? Is it in their office? And then, why are you doing this anyway? A lot of this was from the previous section, but these are important questions because the information actually starts to touch the people. So, as a result, one of the first things you're going to have to think about is, okay, well, then what framework are we going to have for integrating our data? What I mean by, or rather what Sherman means by this is, what do we have to, sorry, bring stuff from inside and outside the enterprise to facilitate um, this information. Now, this is very similar to the last chapter we had discussed, where essentially that chapter was about what is your data architecture. But an integration framework is not the data architecture. It's actually simply now that we've thought about at least tidying up the data for consumption. It'd be the difference between if we had like a delivery truck. Think of, and this isn't going to work if you're only a remote student, but think of the campus convenience store. If you just had a delivery truck dump all that stuff in the middle of the floor, sure, that's all the data you need, but it's not really ready to make, be transitioned into a very sane purchase. So the integration framework architecture is saying, well, how are we going to go from the types of data and the sources that we know we need to the feeding the business intelligence tools. And then, I love the double-sided arrows there because this is over on the right-hand side, because optimally these decisions here work themselves back into the various data sources, which then integrate with fresh data. So we need to undertake at the top of the diagram some profiling and some modeling. And the modeling is essentially saying, based on things we want or we have, how would you redesign it to really fit your needs? And each of these data marts The difference between a data house, a data warehouse, and a data mart is sometimes the data marts are far more purpose for a functional unit, for a particular maybe focus towards some kind of business, some client, some customer. If I were providing goods and services and I had a customer like Boeing or Lockheed Martin, I'd probably build some things. They're such a big shark of a customer. I'd probably build some, ready-made queries and processed information for their ease of access and to really keep track of that relationship because it's such a big money relationship. Let's say we're some sort of part supplier for their aircraft. So you're always going to have to integrate. Let's take that example I just used. So if I'm some kind of part supplier, let's take the Boeing 787. This is a good, decent graphic from them. So they're boasting, Boeing is, and they're world-class supplier quality, and they have all these places they source from. There's in their 787 product, there's 2.3 million parts, and so you're going to have to, for each of these suppliers, you got somebody supplies the wings and the engine. You're going to have to segment that out a bit, and so that's one idea of the data marting. Franchising and integration, it's similar to that, right? So we would actually sort of franchise customer-facing systems if we were Boeing, as an example. Um, or if you're a part supplier and you're working with Lockheed Martin and Boeing and Airbus and all these other industries around the globe, then it's the other way around, right? So you want to segment out them. At all points, then, to kind of keep track of the big picture of what this means, you have this concept of metadata, which is data that describes data. And you're still going to then transform for that integration and franchising out of your warehouse. And then we basically have our prep and integration, which is coming from these sources. So it's interesting how we end up reshuffling this deck depending on what we're discussing. So this entails some processes. So for instance, these reference or dimension tables are essentially um, almost the model, and this is hence into modeling, that we're trying to adhere to so that the data will be most prepared to enter into the data warehouse to move over to um, operational data systems or data marts or any variations of these. I think that they're all essentially um, digested or at least chewed data ready to provide the nutrients required of this information, what this information gives. So we have to gather it. We're almost always going to have to reformat it. You've seen that a little bit with the assignment you've done so far already. We have to consolidate and validate, transform it. Sometimes there's further cleansing, missing records. Then finally, it fits the standards to be put away into our warehouse for future consumption. So it has to be prepared. The franchising is really kind of how we go from the warehouse off to these marts or even OLAP cubes, right? So how can we get subsets of this data ready? So to go back to the Boeing example, they're going to have some data depending on if you're a supplier for the wings or the engine or whatnot. So they need to be able to prepare different consumers of what's still coming out of the same warehouse. So they need to filter and subset it, restructure or denormalizing it sometimes depending on, see, denormalization in the relational model, we normalize data to sort of keep it separate, that maximizes, benefits with respect to storage, with respects to keeping the data kind of atomically simple. But sometimes we need to stretch it out or denormalize it, as the case may be. Aggregation or summarizations. So one is bringing the data together. The other is, of course, getting ready to disseminate it. Then there are just various aspects of being ready to send this franchise data, this federated data, off to the various BI tools. So essentially, if you look at even something like Tableau, we definitely have the ability to do data access. We have the ability to transform the data with just some simple operations. We then had the ability to set it up for presentation and analysis. And even the BI manager, we really have the ability with like the public service through Tableau to kind of have like a repository there so that we can really start to look at other people's BI products. So your experience with working with the public service from Tableau is a good analog here. This graphic comes up over and over in the chapters. I'm going to skip through it because we've seen it. It just says that we're there to facilitate multiple types of products. Now, this isn't snapshot data like they're describing from sort of the mainframe times when we had to make a report for the quarter. This stuff is live. It's emergent. It's um, fluctuates in real time. So data management says that we need ways to keep track of the evolution of this data. So we're going to still have a data integration framework, and sometimes that means as we're transforming data information, we also need to be able to, as a result of these analyses, the various products, be able to work that back in. So we still have staging here, which is related to data preparation. And there's two components here. We still want to be able to update our data about data, but we need to update our models and our profiles depending on how things change, right? The new circumstances. We need to be able to be willing to change the assumptions in our decision making. And the franchising requires its own staging because this is where we're going to subset the data out into data marts and OLAP cubes and whatnot. So this then leads to kind of a more comprehensive environment for our BI. So this comprehensive environment just really implies that we have all the pieces ready to move here. We have our analytical BI component, right? So we have our marts and our operational data stores and all these things that kind of really represent information that's ready to go towards your intelligence. And then we actually have to reconcile that with the operational BI, which is that how is new data coming in? So in a lot of ways, this is almost the way the human brain works. Assume that the left here is the hemisphere that talks about concepts and knowledge you've already internalized. This is fun, that's hot, um, this is going to be difficult. And then you always want to take new pieces of information and metaphorically compare them to the existing frameworks. And so just as this is how the difference between analytical and operational works is kind of how your mind deals with new data. Let me see if I can find this guy on the divided brain. It's from this book called The Master and His Emissary. Ian McGilchrist talks about these different parts of the brain. It's actually a pretty great video to watch at some point. And it really just sort of discusses, our divided brain and what this means for how we work, right? And so these are worth watching. Okay, so that, oops, let me go back to my McGilchrist here. That's definitely certainly worth seeing. And if we look at maybe an image of the divided brain, let me see if I can find a decent one. Not one that's not caught up in that infographic. Oh yeah, Duck Rabbit's a good one. I've used that before. This one might be decent. Yeah, this one's decent. It's even there to reconcile between reason and imagination. So reason is your ability to say, well, what are the patterns I already know Imagination is the ability to extrapolate from. Now, new information is going to change that dynamic, change that mechanism. So the idea here is that reason is based on what we know here, but new sources have to be reconciled between things we've never encountered and things that are novel, that is, or things that we can quickly analyze. Imagination is to kind of even think of new categories or at least permutations of these categories. I'm not doing um, the material great justice here, but it really just talks about how our two different brains, sides of our brains, left brain, right brain, really um, help us to reconcile with new and emergent phenomenon. Let me see if I can find something decent on that. Yeah, this one's decent. I mean, I don't love it, but it gives a sense of what I'm talking about. So, our left brain is logical and analytical and all that, and then the right brain is sort of, hey, I've got the ability to imagine. What this has to do with the metaphor here is that, believe it or not, um, this data feeds against your existing governing variables and what you assume is right and wrong, because they have to be. Don't forget, data warehousing is the ability to be ready to feed the business intelligence products that kind of take us from information to useful or meaningful knowledge, right? That's the intelligence. Intelligence is to keep this entire system fluid. Let me move on to chapter 6. So chapter 6 kind of continues this discussion, and it continues the discussion in favor of thinking on, well, how are we going to really deal with this business of keeping track of all this? So it's sort of like, okay, I've made a decision. What's that going to do? And so in a lot of ways, we're kind of back to the topic of data architecture. When we started off, we talked about an overall architectural framework that was going to infuse the data, the technical, and the product. And then we actually, to start with, talked about our data design. I'm sorry, about our information tech architecture. But we then want to talk about the data architecture. So don't forget, the data is the empirical, fresh sensing of new information that can either confirm or disconfirm our the assumptions in our information architecture. So um, really, it's everything here in the middle, working with these systems of record. So we've seen this before. So the idea of the data mart is that it's going to be generally independent of the entire warehouse. It's there to usually facilitate some subset of operations. You could see more complex organizations. I'll bet you the U.S. military, like, I don't know, the Army would be a good example of, they're going to keep a lot of separate data marts, and they themselves have to come from a common root. Operational data store is really somewhere in between the warehouse and the systems of record, where Amazon's a good example. They have a lot of daily operations that they'll need to then reconcile further to kind of the next stage of data information is, what does this all mean? Federating the data warehouses just sort of says that we have these perhaps geographically distributed, some kind of distribution where it does make sense that we have to um, really keep two separate warehouses. One example could be, if I think of the Ford Motor Company and their operations in Europe versus their operations in North America, um, they're still going to have a lot of commonality. But if you look at the customer preference and the shaping of law and access to resources and just the way the rules of the road work and all these things make it so different. And that's why Ford Motor Company is a good example, and GM would be as well. You go into a different market in a region of the world, and it's not even the same models. For instance, we have this kind of larger need for pickup trucks and large vehicles in the U.S., but Ford would probably not sell nearly as many of those, if any at all, in a place like Europe, Western, Central, Northern Europe. Um, There's just a lot of other factors. So these are reasons why, and they do need to be federated. Don't forget, it's still the Ford Motor Company, but they would operate just so vastly different in certain regions that you're really going to have things separated here. Now it gets really complex because you essentially might have multiple data warehouses, multiple operational data systems. Ford's still a good example of this. They have lots of systems of records, multiple data warehouses and operational data stores. And this is going to lead to fulfilling a lot of different data marts, right? The data mart for, I don't know, regulation and government compliance in the European Union versus the data mart for the UK market versus the data mart for part suppliers in Central America. I mean, and then all these things need to be brought together in BI tools to get a comprehensive sense of it. And that's why, in a lot of ways, this is barely a monolithical company. It's still the Ford Motor Corporation, but it's a lot of degrees of freedom here. So one way you can do this, of course, is to kind of collapse back on it and say, this is too much. And I've seen the ebb and flow of this for the entire time I've been paying attention. The ebb and flow of IT in general to in-user computing, distribution back out to functional units out in the satellite areas to this is a mess, we need to bring it back in central to yes, but we have local and regional needs that are acute, and it just goes back and forth. And I don't think one is correct versus the other. Um, and this is kind of why, in the chapter he talks about, the rise of the enterprise data warehouse again, and that sometimes as much as we have hub and spoke as the best architecture, um, there are times where we're going to need a different approach, right? Um, we're going to need just ability to have you know what's the best way to put it? Sometimes there are costs and sort of data integrity issues that say, no, we've got to sort of reaggregate it, re-centralize it. And I think that this is an ebb and flow that seems to go back and forth over time. So the book talks about kind of these two, um, with respect to best practices and approaches, these two well-known architectures, one from um, Inman and one from Kimball here. And there's some websites to go to for each. So for instance, the corporate information factory is the whole Inman um, approach, and you can get certified in this, and it becomes its own cottage industry, to be honest. There's nothing wrong with it. It's fine. So that's the Inman approach, right? The corporate information factory. So our operational systems feed an integration transformation layer. So integration, extraction and loading, um, that kind of thing. Extraction, transformation, loading. We're going to then feed an enterprise data warehouse, which has some, further for the purposes of delivery, some further extraction, transformation, loading off to the departmental data marts. We're going to sort of keep a separate version out there for more what if and exploration. And then we're going to have an operational data store for operational reporting. And so this segmentation here is part of this corporate information factory concept from Bill Inman. Okay, that's great. So we have that one conceptualization. Um, Another, which I just lost. I'm sorry. Let me see. Let me get back to it. Sherman, but it's Kimball here. Okay. Um, and let me get back to these. Kimball, which should give you the Kimball group, right? Which has a bunch of their own resources and books and kind of a little bit less of a certification cottage industry there. But Kimball's assumptions um, is a lot more of this data bus. So the idea of a bus, particularly with information or even energy transfer, um, is it's just a conduit for the flow, um, usually of energy or um, information in our case. I'm just trying to find a decent definition of this. Yeah, it's a computing term. It's not the only place for it, but um, the idea of a bus is essentially, this is a decent example. It's just a flow conduit, right? But it also means it's linear. So linearly, we'll go from our source systems to kind of a grand extraction, transformation, and loading, where that's been sort of pre-targeted to the various marts, the various, it's just, let's just say it goes to your enterprise data warehousing architecture, which itself acts as a bus, which is in. So it's all very linear, very waterfall. I don't think either of these and becoming orthodox about either of these is nearly as important as just understand that this has to be anticipated and planned for. So this gives you an analytical data architecture, which really says I take a view of my data not from operations, not from anything else, but from this idea of that I have systems of analytics. All of this is there to help me make analytical decisions. Now, that's not necessarily true. It's just a design perspective that at least has to be accommodated in the overall architecture and design. Um, but there's nothing particularly new about this. It just sort of shows that the centricity of the planning, the architecture itself, is there to facilitate the BI schema, which is there to facilitate the BI function. So it really just is a matter of who do you think is most important, right? If I'm, let's see, expeditionary Marines, from the United States Marines being sent off somewhere, is the boat more important, or is the vehicles that we use to land on the shore and go do our business more important? And if you ask the soldier, they'll have one answer. If you ask the captain of the boat, they'll have another answer. So that's kind of understandable. So this creates a workflow that we can see sort of a aggregation and disaggregation through the warehouse. And all this requires work for integration. It's not going to be magical. So we would have a data integration workflow that could be hub and spoke. And the idea is you're hubbing up in the enterprise data warehouse and everything will come to and from there. You could have a workflow that's a system of data integration data stores. So the idea there is it's particularly viewable here in the center, is that we're there to integrate um, more than one source, and we go through the staging and integration schema, but it's really there to um, um, federate out to the data marts. The difference here is the ability for mediation and moderation here in the middle through this operational reporting. So that's a lot more realistic, I think, in terms of the emergent needs for all this type of information, all this type of data. It's a lot more realistic, um, but it's just one conceptualization. Um, and then we have, systems of integration and systems of analytics, which really then sort of says that, well, the truth is, what matters is what we put together for um, the business intelligence component and the rest of it. So this is not to say that this is any different, that one's any different from the other. I think that's just changes, they're different views. Um, so there's the last part of this chapter talks about kind of this restoration of, these are all just functions within data warehousing. And we can caught up on these being centric in this one component or one capacity or that. But at the end of the day, it's pretty simple steps. We go from the systems of record, the ability to prepare data so it can be consumed in business intelligence products. And these things might matter maybe behind the scenes, but out where the rubber meets the road in operations, it doesn't matter. So the back to the future is, hey, at the end of the day, it's just an enterprise data warehouse, and this is the black box view of it. In fact, if you look at the previous slide, it says, hey, this is what's going on in the guts, but does the business intelligence, does the person consuming it care? And the answer is no. So it just depends on whose perspective. Now let's go through the last chapter of the readings we had. And again, this video is a little late. These readings were actually from a week prior, but I thought it was worth putting up something that's a discussion on them. Back to this picture. So it's a great picture. It just kind of reminds us of this progression to current time and beyond, really. In that we have to concern ourselves after having looked at the information architecture, after having thought about the data architecture. The last parts of the overall architecture is to think of what are the facilitating technologies and then the products we'll use where the technologies are manifest in the products. So the technology architecture really just sort of talks about the need to have products for technologies, rather, for information access and data integration, which then kind of leads you in through the entire substrate or the parts below the line, which is the data warehousing and data sources. So these are all what's feeding it, but what we need is we need to be able to stage and pre-digest for access and integration. And you're going to have your own information and access integration between these two sides of the brain, so to speak. The data warehousing, this is the repository of the known models, and the data sources of real-time potential modifications to that. So not very different. We have different styles. We've seen that before. But I like this one quite a bit, so I'm going to spend some time here. So what this means then, and we're going to dabble in some of this stuff quite soon. How are you going to get it actually, right? How do you go from the sources to the targets? What is the actual down in the weeds? So we have some integration applications, things that are literally meant to take the sources and sort of get them into a easily digestible format, easily digestible transactions or transformations. So Internet of Things, B2B, application services, these are all coming from various sources. Now we get them ready for integration through, all these different components here, data virtualization and um, XML, JSON. But this really comes down to then having the correct APIs to go to each type of target. So things like open database connectivity, Java database connectivity, XML, XQuery, which is a XSLT. It's a way to kind of traverse XML, and even just native data APIs, native data APIs. Can't say that quickly. Kind of legacy or proprietary. One that didn't make his list, which is probably a little disappointing, is representational state transfer. It's kind of implied by integration services with that JSON there, but that's far more prominent even a couple years later than presumably when they made the book. So, as a technology, you need to understand exactly how you're going to extract, transform, and load. This can't be, oh, it's going to be done. We need to know these tools exactly. So, we also can have a different conceptualization of it where loading and transformation are usually kind of combined, co-located. It's usually where the product that you're implementing actually does some of these things. It's a more sophisticated product. Oracle and SQL Server and even DB2 from Microsoft come into play there. So this is just a reminder of this is what the databases have to facilitate. And then we kind of end off that chapter with a little bit of a discussion on what this means in terms of shaping the data, what this means in terms of doing some modeling. What is the design of the data? So, oops, sorry, just trying to get something to open on the side here. So this means that we need to look at how these things have evolved and how this is going to allow us to really put these pieces together. Now, it's a nice part of the book where he says, what's the difference between ETL and ELT? where I kind of actually end up, you know, interchangeably using them. But the difference are the where, when, and how they perform. So classic ETL, extraction, transformation, and loading, is what we've seen pretty commonly. So that's kind of like the real standard report writing kind of thing. Um, the ETL, I'm sorry, that's the classic one. ELT is just sort of assuming that the loading and transformation um, are happening really on the system side, and that the reporting itself is an extract. So on the top consideration, uh, which is here, the reason it goes extract, transformation, and load is that we're talking about how we're going to get data from these various operational source systems of record, um, into some sort of data integration so we can get it off to the target database. Whereas we combine some of these concerns here, and it's usually um, has to do with them being combined in the product. One of the last pictures we'll kind of look at is, what are some of the strategies in actually implementing these things, implementing these architectures. And the strategy usually has to do with, on the one hand, we want to design things very well, so that, in the typical relational model here, this is resilient. It has a number of really important properties that allow for us to be certain that um, the data will remain in a high state of integrity. So, pardon me. So, getting things into a relational table have the advantage of atomicity. So, the idea is that the transactions we use to be able to access this data will be kind of narrow and singly defined. So, here's the ACID properties from Microsoft here. So atomicity property identifies a transaction as atomic. An atomic transaction is either fully completed or it's not, and so it keeps things discrete. Consistency says the system is not in perturbation, permanently upset. We want to be able to keep things isolated from each other so that we don't have sort of muddy, dirty reads or dirty writes. And then we need to, as things scale, remain some durability. So that's going to do all that for you. But one issue or concern becomes, but oftentimes we need then the expedience of retrieval, of search and retrieve. So you get a lot of resilience out of going for a relational database management system design, but then you have a lot of penalties to pay because you're kind of having to put the pieces back together for every query. Highly denormalized data, all the way down to actually saying, hey, let's make each part component its own columnar table. And the utility of this is that the efficiency of search, or the efficiency of retrieval, becomes much greater, particularly in a kind of a operating system that's sort of more server side. That's going to be a lot of um, sort of, if you have a lot of transactions, a lot of requests, then you want to probably present views of this data that are highly denormalized, right? So as long as these things can be rejoined with some sort of key, and this just has to do with really uh, having data ready for consumption in processing. So query processing will sped up in this columnar approach because they're all indexed automatically. You can still, because it's columnar, re-relate the data, particularly if you don't let it, become lost. And then we have um, a lot of queries are only just using parts of tables anyway. So instead of having to process or take into account the entire table. So that's just this process of denormalization that becomes very common. All right, that's a whirlwind. It's 49 slides. I apologize, but I thought it was worth at least having some sort of discussion on what to take out of here. So if we look at the major parts, which is definitely how I've divided our traversal of the book, The major parts are, in the first week, we talked about business and technical needs. We talked about in this subsequent week, which is really last week, this is really into the third week here, architectural frameworks. Um, we'll then move on to is to look at how we've blown all these up here. We have the architecture for information, the architecture for data, and the architecture for technology and product. We want to tease those out by looking at data design in the next couple of chapters, integration design, and then ultimately looking at BI design overall. Um, Probably won't have as much time for kind of the last couple chapters of the book, but we'll at least get the big picture here. These incidentally correspond to the big picture, right? If we go far back up here, um, quite a bit back to where we came from here. So we want to have data design. We want to have integration design. Then we want to have business intelligence design. And that's kind of how we'll prosecute the rest of the material. That's all for now. I'll follow us up pretty quickly with the video where the topic is kind of like your next assignment here in the last part of June. And I'll have you playing a lot more with data sources directly and doing things of that nature. So until then, I appreciate you paying attention to this, and we'll be seeing you soon.